Hello everyone, welcome back to the learning field. So we are solving the West Bengal set 2025 Pyqs. So in the last lecture we have covered the abstract algebra. Okay, so already we have take 5 lecture on the West Bengal set 2025 uh, solution series of mathematical science. This is the sixth lecture. This is the sixth lecture, and in this lecture we'll discuss the questions from a real analysis. So you all know that real analysis is the most important topic for any exam. So let's start, and before starting, I am requesting you to all those who are new in my channel, please give a like to this video. Don't forget to subscribe. Definitely do subscribe this channel those who are new, and comment if you have any doubt in the comment section below. So the first question of today's lecture is this one. This says that uh, and all the questions are from X series. All the questions are from X series. So let S less equal to be a poset. A subset T of S possesses. So what is the poset? Poset means actually partially ordered set. Partially ordered set. And what is the definition of partially ordered set? A pair, suppose S this less equal to, which is given in our question, uh, where this S is a set and this less equal to is a partial ordered relation. Fine. And this poset satisfies the most important three properties, which is reflexive property. Second one is antisymmetry property, and third one is the transitivity property. So these are the basic uh, facts related to the poset. And one more thing is that, which is the question actually. So the two important statement is that if if a least upper bound, that is LUB, exists, then it is unique or poset. And number two, similarly, if a GLB, that is the greatest lower bound, exists, then it is unique. So if exist, then unique. So one case is that may not exist. This case can also be considered. Here it is not said that it definitely exists. If exists, then unique. That means what happens in this question is that at most one. If exists, then one. If does not exist, then number of LUB is 0. That means at most one LUB and at most one GLB is the correct answer of this problem. Next question says that, question number 50. Which of the following sets is countably infinite? So I think these questions don't need the actually solution, means explanation, because we all know that the set of all finite subset of n is countable, that is countably infinite, because n is an countable set. So directly option A is our answer. So now if we see options A, C or D to discard these options, see for the first option, the series has two choice, n equal to given 1 or 2, right? So what happened? Uh, Total number of sequence, how many? Total number of sequence, this type sequence is equal to 2 to the power n, and which is uncountable, right? Which is uncountable. Therefore, we can discard this option. Then in this case also, this infinite intersection of minus 1 by 1 means actually this is nothing but 0. So that means 0, mm, uh, 0, this means difference q, which is actually what? 0. That means this is not a countable set, this is a finite set. And in this case also, what happened? If we take this case, infinite intersection of this, then only we get one set. Each set is exactly, because if we take first one, then two element set, 1 by 2, then 1 by 2, 1 by 3, like this. And if we take all the sets are intersection, then each set is exactly equal to what? 1. So this is also not a countable set. So you can discard this option also, or directly option B is the correct answer from the properties of this. This is statements, actually a very famous statements of real analysis. If you did real analysis, then definitely you should read this question at this statement. Now, question number 51 says that f from R to R, it is given that defined by fx equal to 1 and 0, x belongs to q, x belongs to R difference q, R minus q or R difference q. So what is this name of this function? We all know that this function is well known as Dirichlet function. And what is the most famous property of this function? This function is not continuous. Okay, we all know that not continuous at any real number. So that means it is directly the option answer is continuous nowhere. Option B is the correct. These two options are incorrect because rational and irrational relational are part of real numbers. So we can discard these two options. And continuous everywhere, you can just see this question. This is not nowhere continuous. Next is this one. The question says that if R2R is differentiable function, hmm, and R2R differentiable, fine. That means function is obviously continuous. That means this is obviously existent. There is no questions of existence of f. F must exist. Fine. Now given that limit x tending to infinity f dash x, this is equal to 1. So what is the meaning of this question? So that means for sufficiently large m, we can write for for sufficiently large m, we can write that mod of f dash x minus 1 is less than any epsilon. We can take this epsilon as half. Fine. That means by mean value theorem, we can write for a greater than y, what greater than m, x, y are sufficiently larger than m, fx minus fy obviously equal to f dash c into x minus y, where c belongs to xy or yx, you can say this one. Fine. And this is greater than half into xy, half x minus y. That means as x tends to infinity, this portion definitely goes to infinity. That means what? This fx is unbounded. Fx is unbounded. Otherwise, you can take, so directly this is like proof of this question. So option C is our correct answer. Fine. Option C. Also, you can take as this function is 1. So we can choose by example fx equal to like x plus any constant. But based on that, that means it is not bounded. You can discard this option. f dash is bounded, f dash equal to 1, so you cannot discard this option by this example. Or f is increasing, you cannot say, because you don't know whether x goes to minus infinity or positive infinity, because here total r to r is considered, considered here, right? So this is basic, like, uh, uh, we can take that this is like, how can we so that this f is unbounded. Okay, next question. This one, this question says that for a real number x greater than 0, given fx, this is equal to integration x square to 4x square sine of root over t dt. Fine. So this is, and you have to find the f dash. That is, this is differential over integral. So we know that the rule of differential over integral, which is known as, well known as, Leibniz rule. Fine. Leibniz rule. What it says that, if fx equal to this type integration ax to bx and ft dt, then df dt equal to what? Df dt equal to integration ax to bx del x of ft dt plus what? F of bx into b dash x minus f of ax into a dash x. Now, since this is a function of t, so this tends to 0. That means here we only get these two functions. So here, what, ax equal to what? Ax equal to x square and bx equal to 4x square. That means f of bx means what? F of bx means this is sine 4x square means 2x into ddx of 4x square means 8x minus f of x means sine of root under x square, which gives sine x, and a dash x means 2x. Fine. So this is the f dash value. So f dash at pi by 2 is equal to sine 2 pi into pi by 2 means 0 minus sine pi by 2 is 1, 2 into pi by 2 means pi. That is minus pi is our answer. F dash equal to minus pi. Option B is our answer. Next question. So this is the questions from improper integral. So the question says that consider the improper integral I1 equal to integration I1 equal to integral 1 to infinity dx by x root under x square plus 1. Right? So you can observe that this integral is of first kind. Right? This integral, improper integral, is of first kind. Now we can write 1 by x plus x into root under x square plus 1, which is less equal to 1 by x into x. This is x square plus 1, since x square plus 1 is greater than x square. If we square root, then this one. So 1 by root under of x square plus 1 is less than 1 by root under x square, which is equal to 1 by x. So this one, that this is equal to 1 by x square. Now if we apply anything, then this will, by comparison test, this will be true. And we all know that if this is an improper integral of first kind, this is like 1 by x to the power p, where p is greater than 1. And in this case, we all know that 1 by p series, that is p, this is definitely convergent. Therefore, integration, this is convergent means this is also convergent, because this is convergent means this function is also comparison by comparison test. Okay, that means 1 to infinity dx by x root under x square plus 1 dx is convergent. Number 2, what is given? I2. So I2 equal to integration 0 to infinity e to the power minus x square dx. So this is a very common integration and integrand. We can definitely do the integration. So you can say that if we get any finite value of this integration, then this may be definitely, sorry, this definitely convergent. And we all know that you can see this. This is known as Gaussian integral, which is definitely convergent. We can also find the value. So how can we find the value? So let x square equal to t. We use here the gamma integration 0 to infinity e to the power minus x to the power n minus 1 dx. This is equal to gamma n. This we use this formula. So if x square equal to t, then dx equal to dt by 2x dx 2 root t. So it plus, and as x tends to 0, t tends to 0, x tends to infinity, t tends to infinity. Therefore, there is no change in limit. This is equal to integration 0 to infinity e to the power minus t into dt by root t. That means t to the power minus half into dt. We can write integration 0 to infinity e to the power minus t into t to the power half minus 1 dt. Therefore, n value is half. Therefore, this value of this integration is gamma half. And we all know that the value of gamma half is power of pi. Fine. So, and 1 half is outside this integral. 1 half. So, this is actually half gamma half, half pi by 2. So, this is a finite value. That means this is also convergent. Therefore, both the integrals are convergent. Next question. It is from uniform convergent sequence of functions, series of function chapter. So given fn x, this is equal to x to the power n. So we first find the limit function of this sequence of function. So suppose fx is the limit function, it is equal to limit n tends to infinity fn x. This is equal to, see, for 0 is equal to x less than 1. What is the value? 1 by n to the power n. 1 by 1, this is value is 0, and for x equal to 1 the value is 1 to the power n is 1. Therefore, this function fx is not continuous. Okay, so that is at limit x tends to 1, this function is not continuous. That means this function is not continuous throughout the interval. So that means it is piecewise continuous. Fx, we get piecewise limit. So piecewise convergent or pointwise, sorry, pointwise convergent to a, this function fx is discontinuous function. Discontinuous function. So what is the answer? Option D is the answer. So if this is uniformly 0, then what is the formula? We have to check that supremum of x belongs to the interval, suppose here 0 1, okay, mod of fn x minus fx. If this is 0 and limit, obviously limit n tends to infinity, then we say that this is uniformly convergent. But this is not happen. First we have to find the limit function. This is a limit function. Limit function is not continuous. That is, there is no questions of uniform convergence. Fine. Option D is correct. Next question. 57, which is not true. This type of questions are very easy. So first we check for this function. Given that f x y equal to x y cube by x square plus y to the power 6. This is a very common method to show whether this function is continuous or not at 0 0. So we choose the path. Let us choose the path x equal to m y square. Then the degree of numerator and denominator should be same. That means if value of f at x equal to my, so only function of y, which is equal to x equal to m, no, y square, not y square, y cube. So that means we get for x not equal to 0 0, m y to the power 6 by y to the power 6 plus y to the power m square y to the power 6 plus y to the power 6. This is equal to m by 1 plus m square. So limit y tends to 0, only one limit f of y, this value is m by 1 plus m square, which depends on m. That means f is not continuous at 0 0. Fine. F is discontinuous at 0 0. Option B is the answer of this question. Fine. Okay. Next question. Oh, sorry. It says that what is not true. What is not true? That means not true is it is continuous. Fine. It is continuous, not continuous. So this is a question that comes from vector, and I think that I will solve this question to this lecture. So here it is says that in vector calculus, grad divergence of any function, suppose if we take f. So this function, first if we define the divergence, then f should be a vector function, right? Because divergence of f, that is we can write is as div f. If and grad stands for, this operator stands for I del del x. If f is a three variable function, then j del del y plus k del del z, and this is only operate on a vector function f, right? And gradient of this means gradient of this is a vector function, and if we define this in a vector function, then this should be also a vector function. Means should be operated on a vector function that give a vector function. Option B is our correct answer of this question. Both should be vector, otherwise deep grad is not defined. Okay. So these are the questions. The questions are from mainly real analysis, and one question comes from vector that I have included in this video. Fine. So how was the video? If this lecture is helpful for you, then definitely give a like to this video, share it with your friends, and don't forget to subscribe the channel. Okay. Thank you. Bye.